I think this is a very prestigious award for the scientists in the energy area. I think this is a very influential award. For me, this is a very high recognition to my work. I think thanks to the global energy associations, I'm very proud of that. So this is my feeling is very exciting, for that, to receive this, I think this is a moment of great honor for me. Actually, my work is in two different levels. The first level is strategic levels. This means I make the leading scientist and consulting to the government. This is strategic levels. So the organizing, the planning, and the supporting the government policy and strategy. So this is one level. And another more important level is scientific and technology level. In this level, my focus on the power system to electric vehicles. So my major is in energy science and technology. So my work is mainly focused on the power system to electric vehicles, so-called new energy vehicles. So for that, because the electric vehicle, including three different types. The first one is a pure electric vehicle. Second one is hydrogen fuel cell electric vehicles. Also have a third one is the hybrid, plug-in hybrid electric vehicle. But anyway, they have a common technology challenges. The challenge, including the first one, is the battery. Battery is the most important for electric vehicle because I think that 70% of technology of electric vehicle come from the batteries. So the electric vehicle is a product, but this product is based on the technology breakthrough of batteries, the lithium batteries. So one focus for me is batteries. So, but in the battery area, most important to vehicle is the safety. Because the energy density, durability is not so big problem for the lithium battery for electric vehicle. But they have a problem is safety. So the safety problem is the most important for electric vehicle applications because the customer all about the safety of electric vehicle. So this is my duty to do research on the battery safety. So I built the first battery safety laboratory in the world in 2010. So this is because the first electric vehicle safety accident happened in China. So notice that I established this safety laboratory. So for the safety, we have three different aspects to research on the safety. For example, the first aspect we are doing the thermal management. So this means to prevent the battery pack combustion, fire. So this is the first our work. So for that, we have to building the modeling for design the thermal management systems. So second one is actually we call active safety. Active safety means to monitor the battery process. So this is normally used in the control technology. So we call the battery management system. So we are developing the first AI-based large model for battery management, the safety management. So this is second one. The third one, of course, we need to change the material. Because the battery safety depends on the material thermal stability. So we have to improve the thermal stability of the material of the battery. So this is what we call inherent safety. For this purpose, we developed some new material. For example, the EC-free electrolyte, also the safety separator or something like that. And at the last, revolutionized the technology will be the change the traditional liquid electrode to solid liquid. So we are also working on that. I personally initiated the Chinese all-solid-state battery research corporation consortium, and myself is the chairman for that. So the first to promote the safety technology of the batteries. So this is one most important technology for electrical vehicles, because at the moment in Chinese market, 95% of electric vehicle is electric vehicle. So this is most important. But on the other hand, for example, the commercial vehicle. The commercial vehicle will have some hydrogen fuel cell powered heavy duty truck. So this is for commercial vehicle. For commercial vehicle, we are studying the hydrogen fuel cells. So this is normally the PM fuel cells. For that, we have studied for more than 25 years, because this is a very complicated technology. So from a power system to fuel cell engine to fuel cell stack, and also fuel cell membrane, the different technology the levels. So I'm personally involved with this. At the beginning, we are done research on the power system, because the hydrogen fuel cell power system is also complicated. Normally, they need fuel cell with the lithium battery, the hybrid together, because this is, if we only use the fuel cell, there will have a durability problem. So for the fuel cell, the most important things is not safety, it's the durability. So we have to improve the durability to meet the demand of the heavy-duty truck, competed with traditional diesel engine. So this is the most important things. So the first step, we are using the hybrid. We invent a new type of hybrid structures to promote the durability of the hybrid fuel cell hybrid system. So this is the first step. The second step, we are developing a new type of fuel cell engines. For fuel cell engine is a total new technology. We are, personally, I studied the internal combustion engine. So some technology can transfer from a traditional internal combustion engine to fuel cell engine, because the fuel cell engine, the core of the fuel cell engine is a stack, but the engine system is similar. For example, the hydrogen system, the thermal management system, the air systems, almost the same. So this is the second step. The third step, we are down to the heart of the fuel cell. This means a fuel cell stack. Fuel cell stack including the fuel cell membranes. So this is actually thermal process. The thermal process inside these stacks. Actually, these stacks is the fundamental discipline is similar to my original background. This background is chemical physics, physical chemistry, like this. So this is because the energy science, the fundamental energy science is physical chemistry. So despite the different kind of, for example, internal combustion engine, the fuel cell stack, the batteries actually have a common discipline background. So personally, I studied energy science. So this is actually the energy science areas. So it's not so different. If you down to the first principle, it's the same. So we are working on the hydrogen fuel cell almost the same as a battery and also similar to traditional internal combustion engine because they are based on the thermodynamics, the chemistry, almost the same. So I'm doing that. This is my technology focus. But until now, because the situation changed, we have solved the problem of industrial vehicle safety and also the heavy-duty truck, hydrogen fuel cell durability. We have solved that. But at the moment, we are focused shift to energy-related technology. For example, the charge, fast charge, battery swapping, and also hydrogen production. So this is totally energy related. So this is my third sensor technology in the focus. So this is my systems. So one as in the top as technology, strategic technology management and technology leadership. And on the second is technology itself, the basic, the focus of the technology, mainly support on the strategic roadmap to implement. So this is the whole systems. So this is my work. I think despite we have a different, we have many difficulties facing all of the world, we have different values. Anyway, but the climate change, I think let's have a common sense. The energy-related challenge, I think all humans have the common sense. So this is no dispute, no much dispute on the energy-related area. Anyway, we need to concern about the carbon dioxide. We need to make the energy transition to renewable energy. I think this is a common direction for all the countries. So this is no problems. Yeah, we think on this aspect we need international cooperation. For example, personally, also I'm a chief scientist of U.S.-China Industrial Vehicle Cooperation for 10 years. Even though, of course, we have many differences between the U.S. and China, but we are cooperate together on the fundamental research related to industrial vehicle basic technology. For example, the battery, the battery material, and the V2G, the vehicle to grid, something is a very important fundamental research technology to support the further technology progress to transportation electrification put forward. I think this is both for China and the US, we are need that. So if enough, I think my partner also coordinate many years ago. In 2004, I'm a coordinator between European and China for European-China hydrogen corporations. So my partner have many different international cooperation. In my university, my team, we are cooperating with many international companies. For example, the BMW, Benz for battery safety, and also with Toyota on hydrogen fuel cell technology. So that's the international cooperation is very good for all of us because we are the university, we are the scientists, we are served for all over the world because this is for peace, for green development. I think this is a common perspective for all over the world. Now, I think it's a very important starting point. This is the first time I visited Moscow, I visited Russia. It's very impressed for Russia development, for Russia society, for the Moscow beauty. I think I also met many scientists in the energy area. We have meetings together. We have exchanged idea. I think we have a common sense. We are concerned about the future energy, or the direction for the energy of future. Maybe we can cooperate together on what kind of technology roadmap from the fossil fuel-based energy to the renewable-based energy, because this process is very complicated. How to balance the new energy and the traditional energy. And this is a very important issue for both of us. Maybe I think this is a very interesting topic. I would like to cooperate with our Russian partners in the future.